Good afternoon, everybody. I hope you all are having a wonderful and fantastic Friday on today. Lord knows I am, and for that, I am eternally grateful. Today is Friday, May 15th, 2020, and today, on this Freebie Friday episode, I am going to be going over with you how to solve one step equations and two-step equations. Now, if you're looking for a one step that's not what that is. But as it relates to solving equations, okay. So that's what I'll be going over today. So as always, this video was requested by one of my students. So if you would like for me to do a video on a math concept that you are finding that's challenging, or you just want to make sure that you understand it and have a clear understanding of how to work the concept, please drop down in the comment section and I will be sure to do my very best because that's all I can give is my best. Now, remember, and I have to say this with every video, I teach adult education, so I will only be going within the scope of algebra and geometry. If you're looking for trig, if you're looking for calculus, pre-calculus, all of that good stuff, please follow schoolyourself.org. It is a free website. Like I said, they do a great job of breaking things down. And again, I am reteaching myself trigonometry. So that way, when I get comfortable enough, I can teach y'all. But as of right now, I am only going within the scope of algebra and geometry and anything actually below that. So if you need elementary math, fractions, decimals, percents, how to convert them, mean, median, mode, any of those type of things, I'll be more than happy to do a video on those. But please be sure that you drop it down in the comment section so that way I can have time to prepare and give you the best quality content that is out here on these YouTube streets. All right, so let's go ahead and get it cracking because it's Friday. And I don't want to take up too much of your time. I mean, where are we going on this wonderful Friday? Just saying. All right. So first things first, we have to understand what the definition is of an equation. So I'm gonna let y'all read it here. But according to Google, an equation is a statement that values of two mathematical expressions that are equal, which is indicated by the equal sign. Okay. So I wrote the example, something basic, something elementary. For example, 3 plus 5 equals 8 is an equation because when you add the two entities of 3 and 5 together, your result will be equal to 8. And I can prove that with my fingers. So if I have 3 apples and then the Lord blesses me with 5 more, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. So I've just proven that to you. Okay, so 3 plus 5 equals 8 is an equation. Now in algebra, this is a very simple rule, and this is what I always tell my students. You want a variable, which is the letter of the alphabet is 26 of them. And A through Z, you take your pick, is equal to a value. That value can be a number, it can be a decimal, it can be a fraction, it can be positive, it can be negative, it can be whatever. Okay, but you want your letter or your variable to equal a number or some type of value, some type of numerical value. That's what you want. And that's all algebra is. Okay, think of algebra as scales. Okay, you want the scales to balance out. You don't, they start off like this, but the goal is for in algebra, you want your equations to equal. Okay, so that is what we will be discussing on today. All right, so now we're going to take a look into how to solve one-step equations. Now, as I always tell my students, math is a building block. It's a never-ending building block on um, a lot of fundamental things. So if you know how to solve a one-step equation, two-step equations and multi-step equations will not be an issue. So you have to make sure that your foundation is set. And you also have to make sure that the foundations and the fundamentals of algebra which are fractions, decimals, percents, how to convert those three. And then with integers, making sure you know how to add, subtract, multiply, and divide them are strong, because algebra is simply dealing with all of those elements, but in different forms and in different formats. So if you have a very strong foundation on the fundamentals of algebra, this is not going to be an issue. However, if you feel you need more assistance, or you feel you just want, just some extra practice to make sure that you do have it, I would be more than happy to do a video on those as well. Just drop it down in the comment section and I got you. All right. So a few things. I actually did a session because I'm also a private tutor as well. But I also did a session a couple of days ago with one of my students, and I just simply just inserted these examples that I already done to this presentation. Okay, so that's why you see a lot of writing, and I'm probably going to be switching some things around, but you'll get the gist of everything. Okay, now, again, an equation is a mathematical sentence that you solve, and it normally has an equal sign. So that's just the condensed version of the Google definition. Okay, now you have to understand inverse operations. Inverse operations are simply operations that are opposites. It's just the mathematical term for opposite. That's it. All right. So I'm going to make this bigger so that way you all can see it. Because I have to see, and I have bad eyes, so I get it. All right. So the inverse operations are addition and subtraction, and multiplication and division. So in order for you to solve one step, two step, multi-step, any kind of step equations successfully, you must understand how inverses work. Okay, that's very important. So just very quickly, up here, these are all just regular arithmetic problems. We are familiar with these problems. However, they all have equal signs. So because they all have equal signs, this lets us know that we are dealing with equations. Okay. Now, this down here, what I have going in circles with, right? We have 3 plus n equals 8. In algebra, there's going to be a lot of unknowns. I joke and say algebra in some other language means unknown, but that I joke, so that's not true. I'm just joking. But in essence, we want to find a number, a value, something that if we were to replace this variable in for a number, it would make this mathematical sentence true. So that's the reason why I picked the letter N for unknown. I could have picked any other letter. It really doesn't matter. But 3 plus N equals 8. Now we can look at this and say, okay, 3 plus 5 equals 8, because it's a very basic, simple arithmetic problem. However, it's very important that you understand how did we get there? Okay, that's very important. How did we get to 3 plus n equaling 8 to 3 plus 5 equals 8, or n equaling 5? How did we get there? I'm getting ready to tell you. All right. So for one-step equations, it literally takes one step. Okay. So I have already several examples that I've already done here, and I already have put what you would do for each particular problem, but I will go over each of those step by step so that way you can see how these problems work. Okay. So for example, I have here P plus 17 equals 25, right? Now, because this is an addition problem, I must do the inverse operation, or the opposite, which is subtract. Okay. So I am going to subtract 17 from both sides. And as you can see, I've already done all of these problems. But again, I will go over these problems step by step so that way you can see how the concept works. Okay. So once I have done this, I know that a 17 minus 17 gives me a 0. So I know that these two numbers are going to cancel out. And that's the reason why I have put a slash right there to let me know that I don't need those numbers anymore. Now, when it comes to this side, I am going to say 25 minus 17 because whatever I do to one side, I have to do to the other side. Okay. So when I do this, I am left with simply P is equal to 8. Now, what does this mean in the grand scheme of things? Basically, I need to check to make sure that P, in fact, is equal to 8. So what I always tell my students is always check your work. When you get an answer, substitute it back in for the original equation to make sure that it checks out. Because sometimes we may make a mistake. We may do something careless, make a careless error. We may work too fast and we may end up with the wrong answer. So always make sure that you check your work. That's very important. Okay. So, hey, toolbar, I'm going to take my toolbar here. And I am just simply now going to substitute this 8 in for the letter P because they're equal. And because they are both equal, that means I can substitute them back in the equation. So I'm simply going to say 8 plus 17, and I'm going to put 25. Okay. Now, when I add 8 and 17 together, that in fact does give me 25. Okay. So because that gives me 25, I know that 25 equals 25 all day. And because they equal each other, this lets me know that P equals 8 is the correct answer. So you see, it's very important that, again, that you check your work. Always check your work, no matter what type of math you're doing, from arithmetic to calculus and beyond. Make sure that you always check your work. Trust me, I know. All right. So for the next one, I have a subtraction problem. I have S minus 4 equals 20. Okay. Now, because I have a subtraction problem, that means I am going to do the opposite and add 4 to both sides. So as you can see, I've added 4 to on this side and I put it under my 20. Reason being is because, remember, think of it as a scale. You want things to balance out. So my S minus 4 is here and my equals 20 is on this side. And right now they're unbalanced. So the goal is for me to get them to balance. So I will do that by adding 4 to both sides. You can also think of integers as your accounts, making deposits and withdrawals. So what I always tell my students to help them remember with integers, if you were negative $4 in your account and you were just so happen to be blessed to add $4 in your account, that means your balance is at 0. Okay, so that's the reason why, again, I have this slash here to let me know that those two numbers cancel out. So now I bring down my S, and now I'm going to add 20 plus 4, which gives me 24. So S is equal to 24. I'm going to check my answer again, making sure that, in fact, S is equal to 24. Now I'm going to do that at the bottom. So I am going to say 24, because remember, S and 24 are equal, so I can substitute my 24 back in for the letter S. Minus 4 equals 20. Now, when I solve this problem on this side, I am going to get 20 is equal to 20. And I don't know about you, but 20 equals 20 all day. So because 20 equals 20, this lets me know that 24 is indeed my correct answer. Okay, so hopefully so far so good within this lesson. I hope that you are understanding. I hope that if you're watching this as a refresher, I hope that it clicks and you're like, oh, I remember this. Because remember, you've seen this math before. It's just been a while. And that's how I always have to approach math. I tell my students, you've seen it before. It's just been a while. So my job is to help you to refresh and make sure that you get it. Okay. Now, my next problem, and I'm going to switch colors here as soon as I can find my cursor. Okay. My next problem is a multiplication problem. And hopefully you can see it within the background, but it says 6m equals 18. Now, when you have a multiplication problem, you will do the opposite and you will divide the number next to the variable or the letter. Now, before I go any further with that, in algebra, and I tell this to my students as well, in algebra, the multiplication sign goes away. It is no longer 6x3. They do not write it that way in algebra. What they do is they will write it with a coefficient or the number that is in front of the variable with an equal sign. Okay, so I will rewrite the problem here so that way you all can see it. Hopefully you can. 6m equals 18. So this indeed is a multiplication problem. They're not going to say 6 times m. Because in the algebra world, in the algebraic world, that looks like it's saying 6xm. Okay, so they're not going to write multiplication out that way. They also use parentheses in multiplication, and they also sometimes, depending on what books you may see, they may use a dot or an asterisk. But most of the time, they will just simply put a letter and a number together with an equal sign and another number to let you know that that is in fact multiplication. Okay, so I'm going to erase this. All right. So I am now going to divide this equation, this multiplication equation, by 6. The reason why I am dividing by 6 is because, again, you want your letter to be by itself. A lot of times people will do this. And I'm going to write it here so you can see it. And again, I'm not here to math shame or to embarrass. That's not what I do. I am here to help you correct any mistakes or debunk any myths or, just clarify things for you. That's what I'm here for. Okay. So a lot of people will see this problem. Okay. And they will do this. Instead of dividing it by 6, they'll divide it by that number. Okay. And the problem will arise that when you do that, you'll be left with the number 1 on this side, because remember, a number divided by itself or that's over itself is equal to 1, right? And then you will have this 6 over 18. Hopefully y'all can see that, m. And that just leads into more confusing situations. So remember, you always want to divide. When you have a multiplication problem, divide with the number that's next to the variable or next to the letter, okay? So look at the green example. Don't look at the example in black because I'm getting ready to erase it. Okay. All right, and I'm going to go back to the green. Now, when I do this, I am left with m, which is what I want. I want my letter to be by itself because, again, a number that's divided by into itself is 1. Okay, so I'm left with m, and then this is nothing more than a division problem because fractions are nothing more than division problems. So I have 18 is equal, 18 divided by 6 is equal to 3. Now I am going to check my work to make sure that in fact that is correct. So I am going to write in green 6, and I'm going to put in parentheses the number 3. Remember, this denotes multiplication. Okay, I'm not going to write the multiplication sign because in algebra that's not existent. Okay. So now I have 18 is equal to 18. And the last time I checked, 18 equals 18 all day. So because 18 equals 18, this lets me know that 3 is my actual answer. Okay. All right. So far, so good, I hope. Hope you all are really grasping and remembering how to do these things. I'm sorry, y'all. Hold on one quick second. Oh. Sorry, y'all. Got a little distracted. And that's the beautiful thing with Miss Hampton. You get all things in real time. Okay. All right. So with this last problem over here, I'm going to put a box around it. All right. So B divided by 10 is equal to 7. This is a division problem. Okay. Also, let me say this. In algebra, division is written like a fraction, or fractions are division problems. So please understand that anytime you see a fraction, automatically know that that's some type of division, or you may have to divide something. Just wanted to put that out there. Okay. So when you have a division problem, you will do the opposite and you are going to multiply the numbers. So that's exactly what I've done here. I said 10 multiplied by 7. Okay. And B is equal to 70. So what does that mean? That means that if I replace 70 for the letter B back into my original equation, that means my answer when I solve it should come up to be 7. So let's try it. So I have 70 divided by 10. Remember, I have substituted 70 for the letter B because they are equal to each other. So again, anytime you have something that's equal to each other, you can substitute it back in for the original equation to solve. Okay. And the last time I checked, 70 divided by 10 gives me 7, and 7 is equal to 7 all day long. So therefore, B is equal to 70 is my correct answer. Okay. So in short, that is how one-step equations work. Okay. That's really how they go. All right. So again, making sure that you understand how integers work, making sure that you understand how inverse operations work, and above all else, making sure that you are confident in applying these concepts. Because again, you will see these concepts again. They're just going to be presented to you in a different format. So you have to recognize and know when you are looking at a one-step equation, because they're not always going to say this is a one-step equation. Okay. All right. Now, I did some other problems with the last session that I had. And so I wanted to just go over these very, very quickly. I have a plus 9 equals 12. I subtracted 9 from both sides because this is an addition problem. So I had to do the opposite of adding, which is subtracting. So I subtracted 9 from both sides. And when I did that, When I did that, that left me with A is equal to 3. Okay. And of course, we can look at that and say 3 plus 9 does give us 12. Okay. Now, the next 3 are self-explanatory. I just made those up off the top of my dome. And so I wanted to show you all sometimes the problems can be written in many different ways, but you have to make sure that you recognize how they are written. Okay. So back down here, I have 7 plus H equals 15. Sometimes the letters will be in the front, just as all of these problems are. Sometimes the number will be in front, but it just depends. But you are still looking at the sign, and I'm winking for a reason. So when I do this bottom problem, I am going to subtract 7 from both sides, okay? And that's going to leave me with H is equal to 8 because 15 minus 7 gives me 8. Now, that was self-explanatory. The next problem, however, is a little different. And so what I'm going to do is I'm actually going to rewrite this whole entire problem on another board so that way you all can see the process. Okay. And I think that was 30. Yeah, okay. Just wanted to be sure. All right. Now, the first thing you're going to say is, well, I know that this is a subtraction problem. And it is a subtraction problem. However, you are not going to add Z to both sides. And I'm going to tell you why in case you don't know. You cannot add a letter to a number. That is what we call unlike terms. So again, it's very important that the fundamental foundations of algebra are strong. And like terms and unlike terms are a part of that. So if you need a refresher on that, drop it down in the comment section and I'll be more than happy to do a video on that as well. Okay, now I have negative 19 minus Z equals 30. So I have to look at this negative 19 and I have to do something with it. So that means I'm going to add 19 to both sides. No biggie, okay? Now, when I do this, I'm going to cancel that out, and I am going to be left with this. Negative Z is equal to 49. Now, we have a problem. We have another problem. It's a problem on top of problems, right? You cannot have a negative letter or a negative variable. It's okay for your numbers, your fractions, your decimals. It's okay for a numerical value to be negative, but you can't have a negative letter. You just can't have it. So this is what you would have to do. You are going to now have to multiply by -1 on both sides. So if you ever get a negative variable, and I will type this out over here. Actually, I won't type it out because I have it here. So what I'm simply going to do is just copy and paste it to this page. Okay. And I'm going to also make it bigger. So that way you can see it. Okay. 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 So hopefully you all can see that that's watching this video, and I'll put it over here. You cannot have a negative variable. Matter of fact, let me just put it up here. You cannot have a negative variable. It must be positive. You must multiply by -1 on both sides to make your letter positive. Because if you remember the rules of multiplying integers, a negative times a negative gives you a positive. But again, if you need a refresher on that, drop it down and I got you. It'll be on the Freebie Friday video. Okay. So now I am simply just going to multiply my -1 times the negative z. Okay. That's going to be equal to -1 times 49. A negative times a negative gives me a positive. Now, I know what you're thinking. So I'm pretty sure some of y'all are thinking this because I've been doing this a long time. Well, Ms. Hampton, you just said that we cannot add a letter to a number. You're correct. You cannot add a letter to a number. However, you can multiply a letter and a number together. That is called multiplying unlike terms. So you can multiply and divide unlike terms, but you cannot add nor subtract them. Okay, so again, if I need to do a refresher, recap, crash course video on like terms and unlike terms, I got you. No problem. Just let me know. All right, so my answer over here would be Z, and then that will be equal to a negative times a positive, which gives me this -49. So my final answer is actually -49. Now, we are going to prove this because when we prove this, we are going to reinforce another integer rule. And I want to see if anyone can recognize it when I write it out. So I have -19 minus a -49 equals 30. Okay. Now, I'm going to read this out loud so that way you can hear me when I say it. A -19 minus -49 equals 30. I am subtracting two negative numbers. So that means I'm going to have to incorporate the keep, change rule. Okay. So that gives me -19. So I'm going to keep this number the same. I'm going to write keep, change. Some people learned it as keep, change, opposite. Same difference, So I'm going to keep my -19 the same. I am going to change my subtraction sign to addition simply because, again, they are inverse operations. And I am going to change my second number, which is -49, to the opposite, which is 49. Okay. Now, when I do this, when I add a -19 to a positive 49, I do indeed get a positive 30. In another way, if you were -$19 in your account and you put in $49, then you have a balance of $30. Oh, and there's one more way that I can prove this to you, just in case you don't believe me. 49 minus 19. See, we recognize 49 minus 19 as a subtraction problem. But remember, subtraction and addition are inverse operations. So all I simply did was transpose or switch the numbers. And remember, the number takes the sign. So when I switched the numbers, my positive 49 is now in the front, and then my -19, which made it -19, came second. So we recognize this problem, and either way, I still come up with 30. See, no biggie, no problem. All right. So I don't want to make this video too long, but I wanted to break it down to where it makes sense because, again, as your favorite nerdy educator, my job is to make it make sense. Okay. And so that way you can apply it to other mathematical concepts that you may see in the near future. Okay, so what I would like to do is this. I'm going to leave a link in the pinned comment section or in my description box on my channel. And that's going to be a worksheet that you can work on that is solely on one-step equation. Okay, so this is part one of a two-part series. Okay, I probably will be back a little later on to do a part two. So just stay tuned, but I want you all to practice on doing one-step equations and perfecting that particular concept, because again, once you know how to do one-step equations, two-step equations are going to be easy. Multi-step equations are going to be easier. And by the time I'm finished with you, you'll probably be a nerdy educator like myself. Okay? So again, I will leave a link for a practice sheet for you to do with an answer sheet in my pinned comment section and or in the description box. So make sure that you read the description box and or the pinned comment section. Okay. So this was part one. Part two will be coming up soon. So please stay tuned. And again, I'm just really excited. I'm going to stop the screen share. See you later, Tuabar. You've been a great help. All right. So again, thank you all so much for joining me on this Freebie Friday. Um, I may come back with part two later on this evening, but I have to make sure that the videos are processing and I have to make sure that sound quality and things are good on my end. So please let me know if the sound quality is okay, if I have to change up some things. Just try to give things an opportunity to, work out, because that's just what I do. Okay. So again, please make sure that you like, comment, subscribe to this channel, click the notification bell so that every time you can get a video coming from me, you'll be the first one to get it. You ain't got to find it. You ain't got to do nothing. Okay. So again, thank you all so much for joining me on this Freebie Friday, part one of one-step equations. Part two will be two-step equations, and that may be coming up either later on this evening or sometime this weekend. So be on the lookout for it, okay? So remember, your favorite nerdy educator loves you. There's absolutely nothing you can do about it. Be strong, stay safe, practice social distancing, wash your hands, mind your business, stay moisturized. Es muy importante, okay? And stay home. And I'll catch y'all a little bit later or sometime this weekend with part two. All right. Y'all be blessed. Bye.